Zhang. He's a full professor of University of California at Santa Cruz. He's in the chemistry and biochemistry department, and he's one of the his expertise is in the nanophotonics area. He's also editor of the Journal of Physical Chemistry. Well, the idea is he is going to spend these few days. He's going to leave on Thursday. So, any one of you want to talk with him, he's occupying the office just beside where my office is in the second level. So you can visit him, or you can also talk with Dr. Sarara. She can also arrange a meeting with Professor Jin. So, Jin, thank you very much. And the talk that we are going to receive today is about how to prepare a scientific communication or something like that.
Yeah. Okay.
Thank you.
Thank you very much, Elder, for the kind of introduction. Good afternoon, everyone. This is my third time to CIO and also to Liang. My first time was in 11 years ago, and at Elder's invitation. At that meeting, I met many scientists. It was a conference, a network structure conference. Since then, I have established a lot of collaboration with a number of universities and research institutes in Mexico. So I came basically to the country once, on average about once every year, and I always have a very, very good time. So this is my third time here. And as the Elder said, I'll be here for the next few days if you wish to stop by to chat with me, and I'll be happy to chat about research or scientific writing or reviewing. For my talk today, I'll talk about in my role as a senior editor of a journal of physical chemistry, which is the ACS journal, which is the largest JPC in the physical chemistry community. Is the largest journal, I think in terms of ranking and papers. But I hope this talk is not just about JPC or ACS journals. So a lot of things I'll be talking about will be applicable to other journals, physics journal, materials journal, biochemistry journals, hopefully. And I'm not going to talk about science today. As I said, we do research on nanomaterials. I'm an ultrafast laser person. We do work on sensors, solar energy conversion, solid state lighting, cancer detection and therapy. Anyway, you can also look at my webpage. I think I'll show you later. Anyway, if you Google, you'll find me if you want to see what do we do, in case you want to stop by to chat. For the talk today, it's a little bit short notice and also limited time. I'm going to talk about two topics, and focusing on how to basically write a manuscript and how does the peer review process work. Now, at the end, if we have time, depending on how I'm a fast speaker normally, but I know this is not English speaking. I know many of you speak very good English. But again, I'm mindful that this is not an English-speaking country, so I'll try to speak a little more slowly than my normal speed. But in case I do finish quickly about the first two parts, I have a third part. So the third part is only depending on time, which is specifically designed for non-native English speakers, which I give talks also around on behalf of ACS. Actually, I already did twice. Once in University of British Columbia, second time in Stanford. So most of the slides I'll be presenting are from ACS. And I did modify a little bit to fit my need, personal need. But I want to make clear at the beginning, these slides are mostly from ACS. And so let's talk about the first two things first. So this is the ACS way of doing it. So they introduce myself. I know you see me in person, you really don't need it. But sometimes they record this to share with people internationally. Therefore, that's why they have a photo, just put a picture together. So that's a cover page of JPCC, and we have three volumes, JPC A, B, C, now there's a letter, which is separate now. And just for myself, just give you a very quick background. So I did my undergrad in China, in Fudan University in Shanghai. And I came to this country as a non-native speaker. And I learned English for 1 year, 2 years to be correct, writing and reading, not speaking. But when I got a scholarship to come to the US, to University of Washington in Seattle, of course I couldn't speak a thing, okay, any English. So we were put together for 9 months, trained by American teachers from UCLA to learn about American culture, speaking, listening, all those things. So I was young, at least then. I was very confident. So I landed in Seattle. My host family picked me up. He was trying to engage in a conversation with me. I could not speak anything. Okay, I thought I could. I learned all the words, but it just couldn't come out of my mouth. After 6 months it was better. But anyway, one benefit is being sort of young at that time. I was only 21 when I came to the US. And in 1984, so I've been in the US for actually over 30 years now. So anyway, language is one of those things that's no fast fix. You have to spend time doing a little bit every day, and hopefully you pick up a few words, crack a few accents every day, and slowly you become good at it. There's no fast way to fix it. Anyway, I did my PhD at Utah, and a postdoc in Berkeley. And then afterward, I got my first faculty position at UCSC. It's still my position right now. And I was fortunate that I realized later I'm along the West Coast, from Seattle, if you know the geography, based along the Pacific Ocean, moving a little more south every step, from Seattle to Berkeley and to Santa Cruz. And Santa Cruz is a very beautiful town. I don't have a photo in this talk, but for those who know, we are in the middle part of California, along the coast, about 1.5 hours south of San Francisco. We're closer to San Francisco than to Los Angeles, as some people may think we're closer to LA. So anyway, so I've been there for quite a while now. I'm a full professor, I published some papers and 3 books, and I'm an editor for JPC. And that's my email, in case you want to contact me to make an appointment. I do have email access. As I said, I met an elder, my gosh, 15 years ago at least. We both had a less gray hair at that time, or gray beard, that's the deal. And anyway, so time flies. We had a lot of fun, had a collaboration. And he has some students. I spent 1 year in my lab as a visiting student, later on as a visiting postdoc, and then a short time in the summer. I will collaborate with other labs in Mexico and other countries. So scientific research is a global enterprise. So there's a lot of interaction. That's a part of the fun. You meet people, you learn things. Anyway, with that little intro, so here's again JPC. I'm not getting too much details since most of you probably, if you're in the chemistry community, you know these journals. The flagship journals in the physical chemistry community. So a few years ago, JPC later split into a separate journal. Okay, so see here's from ACS, the slides. So the question we're asking is, when I'm ready to write a manuscript? Right? We do research. You do research for fun, okay? For contributing to advancement in science. But also we use publication as a way to communicate with other scientists. The question is, when do I know, especially at the beginning for young students, you may be doing research for several years. The first one is always tricky. I remember my first paper. I was so excited to think about writing it, but it took a long time. And so the first step is always very tricky. And so hopefully this kind of information will help you to think about the first one. If you already have written papers, some of the information still could be useful, hopefully. Okay? So again, we all know what a publication is about. It's sort of like a currency of the profession, okay, to communicate. And also to build blocks that, it's a building block, that defines the body of work. So that, you go to the library, you see a lot of papers. So they're a very important part of the scientific endeavor. So as an individual, so you ask a question, am I ready to write a manuscript? Should I write a paper now? Okay, do I have enough data? Okay, so some of the questions you can ask include, do my data tell a story? Or are they just pieces of information? That's the one question you can ask. And the second question is, do the results obtained, move the state of the knowledge of the field forward? Are we making a really important contribution? And is the information I have collected relevant to others? But these are just some of the questions, not all the questions, as we can see. Okay? So more questions, okay? Or sort of preparation. You can also write a draft, okay? See if it's ready to publish. And that's one way to determine if it's ready. And if the data and results you collected support the major conclusions, this is a very important point. When you do experiment, you also get data. But the data may or may not be useful, may or may not be meaningful. And other people may or may not care to see. Okay? So those are some information. And maybe you need more experiments, okay, when you start to think about writing a paper. I'll say more about this point. The main question you can ask, okay? And also try to review a draft after you write it as if you are doing the work the first time. Sometimes you do this for several years, you forget about the motivation, why you did it in the first place. Okay? Or so much details. You forgot about what other people don't know. Okay? And you may need to add details that will allow others, especially at least experienced colleagues or students, for example, to repeat. That's very important. Sometimes people write papers that are impossible for other people to reproduce. So as editors or reviewers, I'm an author, I'm a reviewer as an editor. So I do all three things. So when I get a paper to review, I'll also make sure the paper looks like the results, experiments are reproducible. If not, you cannot publish. That's one of the important requirements. Okay. So what steps should I take to write a manuscript? That's, as I said, the scary part for the first time. I remember writing my first paper, I gave it to my advisor. I was pretty proud. I thought I did a pretty good job. But that's the old days, okay, you do editing on paper. And we read it, when I got it back, he crossed out about 80% of it. So I feel a little crashed, it's like, I did a lot of work, but I read what he did, I realized, and he was right. Okay? My second paper got much faster and better. So it's a process you have to go through. We all have to go through. Okay, so normally you write following a certain order, okay? The idea is, write manuscript in order of increasing perspective. But this is relevant. You don't have to write this way, even though, as I said, ACS presented this way. Normally you do this way, okay? Methods, results, and discussion. That's logical, okay? This order is logical. But it does not mean you have to write this way. It does not mean you have to write methods first, results second, discussion third. And I'll tell you later what I do know as experienced researcher. I don't write this first, actually. If I were to write a manuscript now. But maybe for a student, this is an easier way to write. I'll also point out which parts are hard, which parts are easy to write. And perhaps you should consider to write what first as we go along. Okay? But generally, those are the parts you would have to consider. And I'll also point out, if I forget, you can ask me questions anytime, okay? And each part contains different information. They are meant for different things. Okay? You don't want to repeat, you don't want to overlap. Each part has a specific function, like the title, abstract, conclusion, references, all have a specific purpose. Okay? Normally this is probably easier because you did experiment, you know the equipment, right? Methods include equipment, chemicals, or computational methods. Results describe your findings. In my experience, for so many years working with many students, I've graduated over 20 PhDs, have over 100 researchers trained through my lab, and grads, visitors. I realized that one of the most difficult parts to write is actually describing results, which was a little surprising to me at first. I thought that should be easy. But every time I started, correct the paper from students or researchers, I realized the part that I thought should be easy, but turned not to be that easy, is results. Just describing results. I'll comment more later, okay? I'll tell you my way of thinking about how to describe results. Okay, so maybe we'll start with the introduction. So this we'll go back to others. Let me briefly cover each part, okay? We'll talk about the title, the important title later. The title is extremely important. You should spend a lot of time to think about your title of your paper. The title can affect the decision of the editor or reviewer in a way more than what you think. You don't have errors in the title, but your title has to be consistent with your story, not exaggerating. Because you set the expectation very high when they read it through your manuscript, the material in your manuscript don't match the title, so they get disappointed. Or you have a really exciting story, your title is underselling the story. So the best title should match the content of the material. So title is very important. Of course, your name and address, those information we also look at for track record. Okay, then following that is the abstract. I'll talk about abstract later. Introduction. What does introduction do? Well, in the introduction, you should summarize what. Let me not follow this word. I'll tell you what, just in my own word, what you should do in the introduction. In the introduction, you need to give the background. You need to put into perspective what your work is about. You start with a general topic, normally broad. Then you narrow down to, let's say, solar cells. Okay, let's say the perfect paper about solar cells. You talk about why solar cells are important. Well, but you don't spend too much time on that because people have done a lot of work on solar cells already. There's no point to write a very long introduction of solar cells, how important it is. Should be just a short paragraph. Very quickly say solar cells are important, what has been done, what questions remain. The point of the introduction is to say what has been done, what has not been done. You see what has not been done to lead toward what you will be doing in your paper. Ideally, this should be question-driven. What has been done, what questions remain. And in this paper, we did whatever. Normally, the last paragraph of the introduction should be a very quick summary of what your paper is about. What has been obtained, what you learned. That's the introduction. What's in abstract? And what's in conclusion? A lot of times people confuse abstract with conclusion. Those are not identical. They have some overlap, but not the same thing. And some authors simply copy the abstract, put in conclusion. We see that as an editor. It's not a property. It's not meant to be that way. Normally, abstract should be written at the very end. Suppose if you're a new researcher, new writer, you write everything except abstract. You should write the abstract last. Why? Because the abstract is supposed to be a summary of everything you did in the piece of paper. So you cannot write it first, normally. Except if you're an experienced researcher, like me now, like an elder, I actually normally write the abstract first. I know it's counterintuitive, but if you think a little more, it makes sense. Because what happens is, by the time you write your paper, more or less your data are already there. So if you're an experienced researcher, you probably know how to interpret the data also. Which means you already know what's going to go into your paper. You have the figures, everything. So that means you're ready to write the summary, like abstract for conference. So what should go into the abstract? Whether you write it before you start the manuscript or at the end. Either way is fine, depending on how experienced you are, how comfortable you are. So what should go into the abstract? You see all kinds of abstract. But what ideal should go in there? In the abstract, you should very briefly. Some journals limit the number of words, 100 words, 250 words, no more than that. Why? Because people can write a very long abstract. Normally, if it's very long, usually means it's not appropriate. An abstract should be about half a page, or third to half page, that's about it, for a typical article. What should go in there is simply what you have done, what you have obtained, what they mean. 3 layers. Necessary. Occasionally, at the end, you can put down a sentence or so about the significance of that. I tend to do that, but not everybody does. So the last one is optional, but the first 3 are necessary. What you have done, what you have obtained, what they mean. Not all details, not what equipment you have used, not all the description of your data. No, nothing like that. That's your abstract. Title, I already talked about the title. The title is very significant, so even though we talk about backward and over. So title, abstract, introduction, that's the order that will appear in your paper. And you go to here methods where they talk about it. Right? So results and discussion. What's the difference between results and discussion? So here's I'm going to tell you one of the challenges I see facing many students, which is about how to describe the results. What's the difference between results and discussion? This is where there's often confusion. Sometimes take several practices to get this right. Now, in some papers, results and discussion are mixed. When you mix them, when you separate them, there's no written rule about it. My rule of thumb is to mix them when it's a small paper, when it's a simple paper. When it's a long paper, a big paper, I separate them. So what is the difference between results, which we say describing your findings, and discussion, putting your findings in context, draw conclusions? But let's talk about results first. In results, normally you just describe your result, describe your data. But that alone is a little tricky. A lot of times people are not describing them properly or not describing enough or overdoing it. Either way is not appropriate. Your description needs to match your results. No more, no less. And you have to assume that the readers can understand the figure in their mind without actually seeing the figure. That's a little tricky. A lot of people assume, oh, figure 1 is the UVVs, therefore I don't need to say that much. No, that's not true. You have to describe it as if the figure is not there, as if the figure is covered. From reading your description, they still understand the figure. I'll give you one example, since I do spectroscopy. Okay, you can see figure 1 shows the UVVs absorption spectrum of gold nanoparticles made, using CTAP as a surfactant. Well, that's just introduce the slide or the figure, but without describing it yet. That's not called description. That's introduction. It's like describing a person. Final comments, I have a little trick telling my students how to separate description versus discussion. Okay? So I can, like I already just introduced me to you. Okay? This is Zhang from UC Santa Cruz. That's just an introduction. He did not describe me at all. How do you describe it? For the UVVs, I would say, okay, there's a very strong peak at 520 nanometer. There's a very weak absorption in the near infrared, or there's some absorption to the blue of the 520 peak. So that's a description. Okay? Using the analogy, the author could have said, if I'm out here, say Jane is 5 feet, 6 inches tall, black hair, wear glasses, right? Wear a blue shirt. That's a description. So without seeing me, you probably have some idea about me before I even came to the room. So that is the description. You have to do that from toe to, head to toe, without saying much more. He didn't say anything about my personality. That's discussion. Okay? So what does 520 peak tell you? Well, normally for people who work with gold nanoparticles, if 520, one peak, that's a strong indication you have gold nanoparticles rather than silver or aluminum or anything like that. So then in discussion, you can say the strong peak at 520 indicates that this is gold nanoparticles. Give a reference. And if the peak is broad or narrow, you can make a further discussion. Okay? The description for the analogy again, the author could have said, Jane is very friendly or very nasty, whatever. That's my personality. That's a description. That's more insight. That means he knew me. Otherwise, he cannot provide this insight. So you need to provide discussion based on your results. These things are related, but not the same thing. So to keep in mind on this point. So we already went over that. Okay. And a lot of little tricks you can use. Once you write it, one of the tricks to use is to give others to read, edit. Okay, your peers or senior colleagues or teachers to see if they think it's good manuscript. Okay. So here are examples. Right? Which journal should I choose? That's always getting difficult, especially with so many new journals coming out every day. Everybody knows they want a good journal, but your paper may or may not be right for Science or Nature, which they reject 90%, because 90%, probably even 95% should not be sent to those journals. Especially in the last few decades. When I was a grad student, I don't read or write. Occasionally I read, but I never considered publishing in Science and Nature. Because it's not appropriate. I'm a physical chemist. I publish in JCP, JPC. I'm very happy. Everybody in the field publishes there. But in the last couple of decades, things are changing. Okay? If you publish a Science and Nature paper, suddenly your career can mean very different things. Okay? So you can argue about what's good, what's bad about that. But anyway, there's a pressure to publish in good journals. But even given that pressure, for whatever reason, you still need to choose the right journal. Otherwise, you're wasting your time. We have seen papers that are sent to 4 or 5 journals. Okay? This Trust Science didn't accept Nature, and then JAX. And then keep going down before it reaches a more realistic journal like JPC or JCP or Chemical Physics. And the problem is more severe in Asian countries, particularly China. I grew up there. They evaluate people based on where the paper is published, the impact factor, all those things. That creates a lot of competition based on those factors. I would say in the US is probably very good in this regard. Okay, when I get a promotion, they don't count just number of papers or impact factors. Okay, I don't know exactly how things are evaluated in Mexico, but I would caution about just going after impact factors. Okay, so the bottom line here is you need to choose the right journal. Okay, right can mean many different things. One, so here are a few, are they relevant for JPC anyway, are they relevant to chemistry community, rather science and nature are more general supposedly, and will the results impact a particular subfield, okay, maybe JPC or DSCP. So you need to make those decisions. Okay. Okay, still on this, and also audience. Who do you want to read? Here's one general. You want to learn about the editor, that's fine, it's not too critical. I'll give you one hint about how editors like me, we decide a paper should be rejected without an external review right away. Okay, some people reject 50% of it, it's getting harder and harder. I usually reject about 5%. I get 400 manuscripts a year to handle, so it's a lot. So right now, I used to reject about 5%. Now, with more experience, I know what I'm looking for, I reject about 30%. Some do 50% or even higher. So you need to, what make an editor, sort of, we use the word jokingly, kill the paper. Normally within 5 minutes you make a decision. Not always, okay? Some people take longer, but some people 5 minutes I already made the decision. So why can we make such a decision so quickly? Well, learn about the editor is one thing, but you need to learn about the audience. How do you know if you're the right audience? One thing is, what paper do you read? Another hint I was going to say is that reference you cite. We reject a lot of papers in JPC that have not a single JPC reference. It happens, believe it or not. It's mostly physics or materials or whatever. That's mostly 90% an indication is not a problem. Not 100%. Okay, occasionally I send a paper out to reviewers, even though it has no JPC reference. When do I do that? That normally means the paper is really exciting or something new. If it's an old topic, like a photocatalysis, you say dye molecule. No, I reject a lot of them. Most editors reject that. Okay, this is the field. People take a dye, put TiO2, monitor UVs, show a few curves, no insight, no new science, try to publish in JPC. 90% of the time doesn't fly. The topic is too old. Even though you have JPC references. But make sure you have the references from the journal you are planning to publish. Any journal, not just JPC. I'm sure other journals do the same. Yeah, so these are just general things. If you're a new writer, you probably want to look at the guidance. These are ACS journals as example. There are a lot of things you can, the books about these things you can look up, as you already experienced. As I said, title. Let's come back to title. Believe it or not, we get manuscripts, not a high chance, but maybe 5% of the time. The errors in the title, either English error or whatever, grammar errors or typos. I will tell you honestly, not just me, all the editors say, that basic English word, turn it off right away. The titles are like a name of a person, okay? All the parents name the kids very carefully. You choose a name very carefully. Same thing here. So this paper is your baby, right? It's your work. So you want to choose the right name. Not too long, not too short, just right. Of course, you want to make sure there's no error at the end. Okay? It just gives people better impression, thinking that you're not a careful or sloppy or something. But you don't want to give the editor reviewers the impression. You want to show your care, you're very careful as a scientist. And all form, that's fine, those are legislative things we have to do. So there are a lot of requirements for different journals you have to do, of course. You need to write a cover letter. I would say, honestly, for me, it's not critical. I don't look at the cover letter that closely because I look at the whole manuscript. But for just some journals, like high impact journals, I think it is very important. You need to write clearly what's significant for science and nature in your cover letter. Yeah, the cover letter normally should include what is a letter, communication, or article review, what type and the title, and you are, submitting on behalf of all co-authors. You can also suggest reviewers. You want to use as reviewer. You can also suggest people you don't want to be a reviewer. And most editors do use suggested reviewers. Roughly, they use probably half. I use about half too. Let's be honest with you. So I choose 4 reviewers normally. I get 2 from the suggestion, 2 I pick. So there's a pretty high chance we use the people you suggest. However, the impression sometimes people have is that if you suggest reviewers, they give you more favorable reviews. That's not true. The reason we are very confident in using suggested reviewers is that, to me anyway, I try the statistics, there's no difference. There's no difference in terms of favorable or unfavorable reviewers between suggested or reviewers editor pick. I was curious about why. Normally, I think the reason is that the reviewers you suggest tend to be people you know, you're familiar with. So then, okay, I'll give you a more favorable review, presumably. Your friends, sort of. But on the other hand, there's a counting factor. Okay? The other factor is people who you choose as friends or reviewers, tend to be experts in your field. People in your field tend to be more critical. That's true whether they know you or not. Because they know the inside story. They tend to know the details. So the 2 factors, in my experience, balance out. So therefore, at the end, there's no major difference between suggested reviewers and reviewers editors pick. You should do that anyway. Normally, if you suggested someone you don't want to use, you need to give a reason. Conflict of interest or competition or something, that's fine. Most editors respect that, but remember, we don't have to do that. It's just a suggestion. Your suggestion is just a suggestion. Normally, we honor the request, but we don't have to. Sometimes people do it on purpose just to see what those reviewers excluded say. But when they get a review back, they keep in mind these reviewers are sort of excluded by the authors. So it depends really on the editor. Again, I already talked about this, okay? You don't have to repeat your abstract in the conclusion or in the cover letter, just say something different. And this is to highlight major findings. Okay, these are resources ACS provide. You can Google them nowadays, it's easy, I'm not going to spend too much time. There's a lot of resources available. Okay, so I'm going to skip over those quickly. We're going to talk about peer review, more specific. So the first part is about manuscript preparation. This is the more specific about peer review. Even though I give you a few things here and there already. Okay. So this is a sort of cartoon. You see, it's not easy to go through the process. And why do we do peer review? Well, overall, there are many reasons. One is to improve the quality of the research. And people make mistakes. Okay. The truth is this: if you write a manuscript, you spend a lot of time. If you put it down for a few weeks, you come back, you always find little errors or things you can improve. That's true for most of us. Right? So reviewers can give you some comments to improve your writing, and they want to maintain high standards in science and provide a measure of credibility. When you become like a researcher, like an elder and me as her, we become more independent one day. Your reputation matters. You want to maintain. Why does it matter? It matters for many reasons. For example, if I send a student to elder as a scientist here, he probably, think about my reputation. If I'm a good scientist, he'll probably trust my letter or recommendation. If I have a bad name out there, and my letter weighs less. So in the community, we start to know people after, some decades. So the name of the PI, the researcher matters, affects him or herself, but also affects students. It's a credibility, as I mentioned earlier. So peer review is to help the editor make a decision. Okay, we send it out. You submit a paper, I get it, I send it out to review by authors. We want to determine if it's original, and if it's scientifically important, and if it fits the journal. Now, original is very important. Sometimes people argue what I've done is new. Now, new is not enough for publication. It normally has to be new and important or significant for publication. Here's the process, roughly. Okay. So let's say the author submit a paper to the main office, like there's an editor-in-chief in our case, JPC in Northwestern University, George Schatz in Chicago. He assigned to an associate editor or senior editor, which is I'm one of them. And we send to reviewers. Okay, can be anywhere between 0 to 5 or 6, depending on the editor. I send to 4. I hope we get 2 back. That's roughly the statistics. And I make a decision about whether I can make a decision even without a review. As I said earlier, we have a 30% in my office. And if we do send to review, the reviews come back to us. I analyze, read the manuscript with the reviewer's comments, and send our decision to the authors. The authors normally revise once or twice, and send it back and then publish. So that's the process. Okay. So some people, of course, the scientific review is not perfect. That's what the next 2 slides is about. Some people question peer review. It doesn't seem to be very fair in some sense. Okay. Let's say you spend a lot of time, 5 years, you get a beautiful piece of work. You send out to review, 2 people made a decision. Maybe 3 adding the editor about if it can publish or not. That sounds a little cruel sometimes, right? Maybe it's published, maybe not. If it publishes, it's great. If not published, 3 people decide whether your paper will be published. Of course, you can always try other journals. Eventually, find a place to publish. But at that moment, it feels like the review system failed you, right? You work so hard, you are very proud of the work. It's not accepted by the journal you submitted to. But we still have to do it, okay? There's another quote from Zhang, Nobel laureate in the next slide or 2. But even though it's not perfect, it's considered as a censorship, fraud, mistakes, and misinformation. And this is a quote from Zhang, okay? And the following is similar. So basically, they say, that's this quote. Says such a censorship, referring to peer review, is hazardous. So it sounds like it's not a very positive comment. But the objective is so important, we still have to do it. So it says that's tall order, but the health of the science depends on it. So it's not perfect, we still have to do it. That's the translation of this point here. And the reason is that we need this, as we said already, to ensure scientific integrity, relevance, and quality. And also importantly, it makes sure your work published is something you're part of for many, many decades. Okay? Your children, your grandchildren, when they see your paper, they feel part of it. Okay? So we want to avoid mistakes. Now, all these mistakes, that's different from fraud or people who copy data or make up data. So that's a different, we catch them, believe it or not. Scientific review does catch, that's a small percentage. Of course, there are a lot of honest mistakes. That's okay, it's acceptable. You want to avoid it, but it happens. That's different from fraud, which people make up data, which it comes out once in a while. By the way, you cannot do some in the manuscript, okay? That happens also. You cannot have one paper submitted to 2 journals at the same time. That's against the rule. Or they change a little bit and submit again. That's also against the rule. A lot of fraud we try to catch and avoid as editors. Okay? Okay, so that's the process. We don't need to go through it. We already threw all it with a chart. Okay, so go through the chief editor, senior editor, and so we can reject if there's no novelty at all. Okay, always a poorly reading. As I said, the first time I talk about some of the common English errors, especially for non-native speakers, it's difficult. I see it all the time. Since I'm a non-native speaker, and I'm sensitive to those issues. But you as an author, you have to try to do the best you can. Okay. So these are the processes. I don't think we need to. Yeah. So it's pretty obvious. Okay. What do we have to do? Oh, what happens if you get rejected? What do you do from there? Well, that depends on the journal. Okay. Let's say you send a paper to JPC, I reject it. Can you appeal? The answer is yes. what's the chance for being successful? You appeal. That depends on the journal. Some journals don't even reply to you. Okay? You appeal, they don't reply to you. That happens. It happened to me, to journals I submitted to. I know that. But JPC is pretty good, okay? And either my office is pretty good. We always reply to you if you appeal. What's the chance for giving you a chance? It depends. Actually, I would say in my office, it's pretty high. Okay? But you have to give a reason. We rejected, you don't agree. You can always write back to the editor, say, I respectfully disagree. Don't get mad, don't get angry, okay? People do that sometimes. That doesn't sell very well when you get angry. Say, thank you very much for your time. Because we all try to help. The reviewers and the editor. Just say, thank you very much for blah, blah, blah. However, I, respectfully disagree with the decision for the following reasons. 1, 2, 3, 4. Give a reason, scientific reason. And I would say, not just me, many editors probably give you a chance to review. All it means just I send it out to more reviewers, or come back or look at it. So the process does give you a chance, second chance, or third chance. Okay. Yeah, so here's what we're talking about. If you get a review back, could be positive or negative. If it's a revision, it's easy. If it's a negative, let's say revision, positive, or major revision. You need to read it very, very carefully, and you need to address every single point of the review. Don't take shortcuts. Believe it or not, we don't read every point, but we sample as an editor. It could just happen the point you skipped is the one we catch. I can also tell you the practice is that some points are harder to address than others. Therefore, people, if they skip a point, they tend to skip the point that's difficult to address. But that's also the point the editor is looking for. Okay? We can very quickly figure out which points are harder to address because we have experience. Okay? If the point is 3 that's difficult, when it comes back, I'm looking for point 3. See how you answer. So make sure you address every point the best you can. You don't have to agree with the reviewers. You can say, we agree, we did this. We don't agree, why? But don't pretend it didn't happen. And we'll not send it back to you again. You have to revise it again. That just costs every time. So address all the points. And yeah, so if you have somehow we cannot resolve it between there's a disagreement between reviewer and author. If after review we still have questions, we can send to more reviewers. That normally takes longer. And if everybody agrees, everything's good, we accept the manuscript. Okay, I understand. I already said, reviewers are trying to help. In very occasionally there's a politics, but it's very rare. Okay, once I get one manuscript was rejected, these authors are upset. So they wrote, they said, I know who this reviewer is, because they had an argument about this point earlier. I can tell you it was not the person the author thought it was. Okay? Because there can be other people who have the same viewpoint from the person you're arguing with. But I cannot tell them. I cannot say, yes, you're right, or no, you're not right. But it was not in that case. So don't second guess who the viewers are. Just do the best you can to revise them. And try to be appreciative. Understand the editors and reviewers try to help you. And we already said these points, okay? But make sure you understand what they're saying. If you don't understand, you can always communicate with the editor. Because you don't know who the reviewers are. You can say, these points are not clear, we don't know how to change it. And the editors can communicate with the author or reviewers to figure out what they really meant to suggest. So that's okay. Yeah, if you don't agree, it's okay. But you need to say why. Don't leave it blank. Okay? Yeah, don't use things like this. Yeah, don't blame the reviewer. So, if the reality is the reviewers are busy, editors are busy. They can make mistakes. It does happen. But even when that happens, instead of saying, this reviewer didn't understand what we are talking about, you can say, perhaps we did not make it clear. So now we revise it. You can change a few words, just make it clearer. So try to take responsibility as author. It always goes well there. Okay? Common mistakes. Okay? If you show any evidence, you didn't care. like you miss some points. Now 3 points in a paragraph, you address 1 or 2. So that's not good. Incomplete revision, okay? You didn't explain why. Even if you don't have the equipment, it's okay. You can say, somebody suggests, if you can do EDX, that'll be great. Just say, in our institution, we don't have EDX. And it's not easy for us to access EDX. This will be something interesting to do in the future. That's a totally fine. Okay? If you don't have a femtosecond laser, just say we don't have easy access to a femtosecond laser. That's okay. I need to address the points. Okay, here things I already mentioned. And people do get emotional. Me too. I was an author. My paper got rejected. I thought it was the best paper I've written in 3 years was rejected. You get emotion. Okay? But I'm more thick-skinned now because I've been practicing for many years, but I still get excited. I'm less excited now because we just see them more. I slap back and forth. And the editor also taught me a lot of lessons, so I become more appreciative of people's care. So do get emotional. If you are emotional, put it down. Don't deal with it that night, okay? Get some coffee or glass of wine. Do it next week or next day. I bet you'll feel different, okay? So try to do that, okay? Yeah, I get GPC. I get rejection from journal, that's no surprise. But I get rejection from JPC. As a JPC editor. It's okay. So, everybody gets it. Yeah, to cool down before you do. Anyway. Okay, so it's near the end of my 2 topics. So that's the ACS slide. These are slides I made long before I was giving this kind of talk. As an editor, because I give research talks, people ask me to say a few words. So this is my word. This repeats, many of the points are repeated, but it's more my summary, right? So the results have to be original, new, and significant. Okay? Not just synthesis, structure, or device for JPC anyway. It has to be well written. Okay? If you have time, I can talk a little bit about that. A few tips about that. It has to be well organized, concise. Okay? Long is not necessarily good. Short may not be good either. It has to be right length. And when you read, you want to read it. But it needs to be complete. And it have good figures. Figures are extremely important. Much more important than what many young writers realize. For seminars, conferences, or papers, figures are extremely important. There are many mistakes people make. Okay? Fonts, quality of figure, line thickness, color, pay attention to those things. Reviewers, editors, try to be fair, as I said, suggest reviewers, I already told you. Of course, don't try to suggest people, obviously they are from the same university, we don't use that, okay? If a Charles has paper suggests an order, we're not going to use it. And as I try to tell, it's easier for editor to accept a paper. Everyone's getting it. It's harder to reject, but we have to sometimes address all points, as I said, we are not. Respond in a timely manner, editors like that, and not get too personal, emotional. And this is beyond those. So this, I generate these 10 points for my own students. I always have new students. As a teacher, you train new students all the time. Once they become good, they graduate. So this cycle repeats every few years. So they ask me questions. So I sort of generalize a few years with these questions about before research project is carried out, and the next slide is the after, about when you write it. When you do a research project, ideally, you should ask these questions. What's the motivation? Why do you do it? If you cannot give a good answer, don't do it. That means you don't have a good motivation. Okay? Then after you decide you have motivation, let's say solar cells, okay, important. What has been done? That means you have to read literature, go to conferences, talk to people who know. And what are the outstanding questions? What questions need to be answered still? This form your introduction, actually, if you can answer all these questions. And then this introduction, essentially, what techniques of which will I use? So that's experimental, laser, whatever, PM. And how do I do it? You need to design the steps. And what results do I expect to get? A spectrum or EM data? And how do I analyze it? Getting data is relatively easy. Analyzing actually is harder. You need to know theory, you need to know software, right? Mathematics. What conclusion do I try to get from this research? Which journal is appropriate, as connected to what we said earlier? What's the timeline for the research? Is it 5 years, 2 years, 3 years? It's hard to predict, but you should have some idea, at least. That's before research. After your research, okay, you got your results. Now we are writing a paper. To write the introduction, connect to what we said earlier, what's the motivation? What has been done? What questions? These 3 points are exactly same on purpose. You need to ask those questions before you do your research. You need to ask them after your research to write your introduction. These points need to be addressed in your introduction. To write your experimental, you need to know the techniques you use, what experiment you have done. These are after, of course. So we already done the experiment. What results did you get? Are they consistent with what you expected? If yes, it's one thing. If not, maybe it's not right. Maybe it's very, very exciting. Right? And is there anything new? Really, you got a lot of data. Do they tell you anything new? Maybe, maybe not. Okay? If yes, you can publish a good journal. If not, you can probably publish, but it's going to be hard to publish a high-quality journal. What conclusions can we draw from this? Those are really the deep insights you learn. Okay? And then same thing, okay, journal, and how to write a paper. That connects what we talked about earlier. So, given all that, really there's no fast solution to all this, and it's a practice. Okay? That's why I give you the background on myself. And it's a practice. Okay? Really, it's practice. And this is including for scientific writing, reading. To write well, you have to read. Develop a habit. Read a few papers a day. Practice to write. Okay? When you read, you think of how you read paper. You put 10 papers. Maybe one you really like, one you really don't like. Ask yourself why you like it, why you don't like it. Try to write the way the paper you like. Right? And listen, speaking, right? Those are language skills. So that's the ACS sort of thing. And I can stop here, but if there's question or interest, there's another small part which was a talk I gave specifically for non-native speakers, where it's more of a language, what kind of common mistakes you want to avoid. But again, I'll be happy to talk about if there's interest, otherwise we can pause here for questions and answers. Thank you so much for your time.
We have time for a few questions.
You have to speak English. Sorry. But I trust you guys are all very good in English.
You grade reviewers. I mean, you give a grade about, okay, do they well? Or?
We don't. Most journals don't. The reviewers, we have very good reviewers. The people do a lot of reviews. We want to reward them. We send them user send a card, and we send a thank you note. But we don't give any monetary or any particular reward. But if you commit any plagiarism or do due submission, there is a called sort of like blacklist if you want. People who have committed offense to the journal multiple times. And one example is multiple submission. I dealt with a few myself. So once I sent the paper, and it happens that one of the reviewers was a suggested reviewer. The suggested reviewer alerted me that the reviewer got another paper from another journal from the same group that are essentially identical. So that's a perfect case of a due submission. By chance we caught it. So in that case, we put the author on the blacklist, and both journals reject the manuscript without a review. So I would say for good authors, reviewers, there's no sort of list, but we do have a list on people who have committed sort of fraud or plagiarism or something like that. But that status can change if the person changes. Basically, you don't want to commit all these offenses, do anything that's not appropriate. Then there's no problem. Is that what you're asking, sort of?
Yeah, because sometimes as a reviewer, I receive a lot of papers to review.
Right.
For particular journals.
Right.
Even though journals I have not published before.
Right.
So I was wondering why.
Yeah, we all do a lot of reviews. Besides 400, I get about 300 papers to review a year. So there's a lot of pressure, a lot of journals. The longer you are in the field, the more you get to review. Because thanks to Google, we like it or not. And that's what I use sometimes. For the title, I don't have enough reviewers. I Google the keywords. If you publish in the field, your name will show up. And that's one way to find reviewers. So the more you publish, the more you will likely be sought as a reviewer, which is fair in some ways. But if you're a very good reviewer, you have more people looking for you.
Yes, but I was wondering if my reviews perhaps.
That's right. But in ACS alone, we have a database. I can see if you review one for us last month or 5 in last year, we can see it. But it's only for our journal. If you review for JCP, for example, we don't know, or for science, we don't know. But you can always say no. Okay? It's totally fine to say no, but the ideal thing is not to just not reply as a reviewer. You can say, I'm very busy, I cannot do it. I do this now. But if the reviewer doesn't reply, it's a problem because we don't know if we can do the review. That's going to delay the review. The authors are anxious in getting the answers. So the editors, we are sort of caught in the middle. But that's a good question.
Any other question?
What about if a paper is rejected? Can I send the same paper to another journal with a different format or with the same format? Is it okay? Or?
Yes, of course you can. Yeah, if your paper is rejected by journal A, you can of course submit to journal B.
With
But
the same title, everything, or
you can do the same everything, unless the journal has a different requirement of references and figures. And some journals now ask, has this paper been submitted to another journal or not? ACS does it. Or has this paper been submitted to another ACS journal or not? Those are two questions. I recommend being honest. Because it's very easy to find out you already did. If you did, you don't say, that's different from you did, you said it. Some people worry, say, oh, I submitted to JAX, was rejected. It looks bad if I tell JPC. That's not true. We don't worry about it. We just want to make sure we know the history. And we evaluate them quite independently. Yeah. So you can always do that. But here's one little catch. If you submit to JCP, we reject it without review. You cannot send the exact same paper again back. If you do, that's considered as not so good a thing you did. You have to make changes. You can make changes and then resubmit. That's fine. And in the letter, you say, this was submitted to JPC last week and was rejected with or without review. Here are the major changes we made, either based on new results or based on the feedback we got from the editor. And we feel now this manuscript is appropriate for JPC. So therefore, we are resubmitting to JPC. That's okay. If they reject it directly, you don't make any changes, you send it back, that is not a good idea.
Any other question? I guess when you remark the response point by point, the question of the referee, it is also important to consider that don't ask don't respond to any other question not asked before. I mean, if you have some comments there or some question of the referee, just respond to that, not any other things, because sometimes can be sentimental, and then we include more information that the referee is not asking, and that can complicate it.
Right, except, I agree totally, except if you, let's say, during the process, you got a better piece of data.
Yeah, sure.
Okay, the spectrum got improved. Or you got some other data that strengthen the paper, which you can do. You can say, in addition to those changes, we just got another piece of data that's very informative or supports the model. We now present as a new figure in blah, blah, that's fine. But in general, you're right. You don't want to add things unnecessarily that can cause complication. Yeah.
How do you deal with unresponsive reviewers in terms of, well, say you ask 4 reviewers to check the paper and after, I don't know, 2 months, you have only 1 response?
Yeah, so this varies significantly from office to office, from people to people. I'll tell you how I do it. So normally we send 4 reviewers. Like today I was reading some of the manuscript I got today from my secretary. I normally assign them within a day or two. So my office is never the bottleneck. The reviewers are the bottleneck. We send to 4 reviewers. We hope all respond, but statistically we get 2. But let's say after 2 weeks, nobody responded. It's rare, but it could happen. Then we know, based on statistics, in 2 weeks nobody responded. That means we're not going to get 2 reviews. We can add more reviewers, and we send a reminder to people, to the reviewers. We already sent, ask them. So basically, my assistant stays on top of things. We're watching this all the time. Try to save time. It's very rare that after 4 weeks, we give a reviewer 4 weeks, we get 0 review. Very rare. But if it happens, we send out to more reviewers, normally alerting the new reviewers that this manuscript was delayed. We would appreciate if you can do the sort of expedite the process. Or honestly, occasionally, I do the review. I don't do it often because I cannot do that often. But if it's something I'm familiar with, like femtosecond laser or SIRS, really that it's hard to find a reviewer, it's already many weeks, I could act as a reviewer. Either act a reviewer or as an editor, I just make a decision. But that's very rare, it's like a few percent at most. Any other questions? Yeah. Please, yeah.
Suppose if same manuscript was rejected from one journal.
I didn't quite catch the first one.
Suppose one manuscript was rejected from the one journal. At the same time, we can send it to some other journal. So that people was accepted. So what is the science in behind that?
I didn't quite catch the first part. You are submitting the same manuscript to two
Yes,
different.
same manuscript. Suppose if you want to reject it from one journal, then we can send it to immediately to some other journals. They will accept.
After you submit to the first one.
Yes, same manuscript.
Yeah,
So one journal people are rejected.
yeah,
In that case, we have to send some other journal.
right.
But that people are accepted.
That's fine.
Yes. So what is the science? Generally, if you want to send, we can see all details of that journal. If it is okay for that journal, we can send. But that people are sometimes rejected.
So I guess I didn't quite get it. So you send to the first journal, they reject it.
Yes.
You turn around very quickly to another journal, they accept it. Right? You know what you're saying?
Yes, some journals are accepted, some
Right.
journals are not accepted.
But again, you cannot submit at the same time. But if you do it in sequence, it's okay.
But the manuscript is the same.
Yeah, that's okay.
So why?
You mean you ask me why they do that?
Why some people are not accepted, some people are accepted.
Well, that depends. Well, that's the whole process. That depends on the reviewers, depends on the editor, depends on the journal. I'll give you one example. In JPC, if you just do synthesis.
So why don't you that people are not read the science?
Oh, no. The rejecting a paper does not mean they do not read the science. Rejecting a paper could mean they determine, the editor and the reviewers together determined that your paper is not appropriate for their journal. No, I review for other journals. I just review it for Nature. It's good work, but it's not good enough for Nature. Because every journal has a standard. The standard is different. Like a proposal, same thing with a proposal. You submit a proposal to an agency, they reject it. You can submit to another agency, maybe they support it. They have a different standard. So it's the quality and the content of the material. That's the sort of part of the point. You have to send your work to the right journal. I'll give you one example. In JPC, I get a lot of solar cell papers that has no science. All they did is they take TL to put a quantum dots, sensitize it, they get a curve. They say, oh, this is better compared to blah, blah, blah. But there's no, I mean, it's good. Maybe it's new. The results could be important, but there's no physical chemistry. There's no insight. In physical chemistry, one of the 5 review criteria is a new physical chemistry insight. So just synthesis, just device, or just characterization, we don't take for JPC. But I'm just using JPC as an example. But Science and Nature have different criteria. We published a paper in Cancer Journal, it was a very good journal. We sent to Nature, they said, oh, it's too specialized. But they publish a lot of very specialized things. For those journals, Science and Nature, they have to be more newsworthy. besides good science, new, they also want the general people on the street want to read, which I don't blame them. That's fine. If that's the, their mission, their target, that's okay. So every journal has a different focus. So that's why you need to determine which journal is appropriate for your work. Rejected by one journal does not mean it's bad science. Does not mean it's not worth publishing. It's just not for their journal, which is fine.
Yes, actually, but sometimes we have seen so many journals based on particular science. So we are also doing same like that, but sometimes we are rejecting from that.
The rejection can be many reasons. I didn't get into it. Track record is one thing. Language is a big part. I didn't talk the figures. I can tell you in my own experience some of the. Okay, let me put this. Used to be in China. I grew up in China. Keep using China as example. Openly, a decade ago, JPC, many research journals say, we need to treat the paper from China a little harder. Okay, which is not fair. You should not say that to any country. You cannot single out China or Mexico or Africa as a region or country, say, oh, we get a lot of bad papers caught from this region, therefore we're going to be harder on those papers. But I do understand them from another perspective, because the English was difficult for many Asian-speaking countries, like Japan or Korea or China. It's getting better over time. I'm talking about, over a decade ago. So writing is a big part. There's an art in writing, okay? Figures. I can tell you, when you put figures together, there's art, there's a science together. Some of the figures, I look at them, the science is good, but the figures are very boring. You don't want to look at them. On the other hand, there are people who publish it in top quality, if you look at them. I know a few people that are very good in presenting data. Same data, but they look very nice. And the example is like people. It's not fair. People, there's a bias about people. Any field, any people. Why do we dress up nicely? We go to, I'll be honest with you, normally I dress up. Today was, I was not planning to present this week, but normally if you tell me ahead of time, I would put my suit on. Well, one is to show respect to the audience. Another one is to, it's a formal setting. I want to look professional to you. So that's a packaging, okay? If I wear shorts, make my hair, half colored, half, whatever. There's nothing wrong, but you will have a different impression of me. So the first impression, actually, I don't know, you are going to let me show you one thing, okay? This is for non-native speakers, but it's true for anybody. Okay, so let me show you one point I'm going to make. I'm not going to cover the whole thing, we don't have time. Where is the point I'm looking for? Yeah, this is what I'm looking for. The 5 or 6 slides on this issue of scientific writing says first impression is everything. So the dress, the hair, I'm just using jokingly, is the first impression. We all have this instinct. When we see people, for a few seconds you form an opinion. It's not just my study, it's scientific. Psychologists study this. And a few seconds, a few minutes interview, that already determine whether you like the person or not. Same thing with a paper. I can tell you 5 minutes, I can already make a decision. I forgot to tell you what I look for. We just had a teleconference with JPC editors last week about how we want to make it consistent. We used to call it RWR, rejection without review. Now we're changing the word into rejection without external review. Because some authors complain, said, oh, we submitted it, you reject without any review. That's not true. It's reviewed by the editors. So the editors, we had a meeting, try to calibrate, to make sure we are doing the same. So we have 6 manuscripts selected, asking all of us to look at it. Amazingly, we all agree on that they should be RWR or RAER, rejection after editorial review. So that means there's something common there we're looking for. I'll tell you a few things. Figure is one big. Let me tell you what I look for in the first few minutes. I make a decision. Title, abstract, figures, references, and the conclusion. Pretty much within 5 minutes, I can make a decision. If I couldn't, that means I probably should go out for review. I send out for review. So the title is important. The conclusion, I look for insights. Okay? If you just say, I made this, I did this, period, it's not going to work for JPC. I'm looking for mechanistic indications. Something significant. What's new? We're looking for, you don't have to use the word new, but we're looking for new things and significant things. compared to your work or other people's work in the past. And if you have experience, normally we handle papers in our field. So I can tell pretty quickly whether it's there or not. But we're not perfect, we're human beings, okay? But that's why we give you a process. If I reject, you don't agree, you can appeal. We can try to deal with it and send out for review. And the reviewers come with comments. If you choose not enough, we send to a third one. If you put it this way, if you really feel strongly your work is appropriate for the journal, it's very significant, very important, it can be published in their journal. And if it's writing, you have to fix it, okay? If the English is written in such a way nobody can understand you, if that's the issue, or the figures are very bad, with no error bars or very thin lines, then you need to fix those. But those are normally easier to fix if you really have good scientific data. Okay.
Okay, any other question?
Go ahead.
Because, well, in the case of students, we are submitting our first manuscript,
Yeah.
and there are a lot of journals,
Yeah.
and so many journals that we don't even know that they exist. So, first, how can I be sure that that's the best journal? I know my references.
Yeah.
That's a good start point, but
Right.
what else? Because we don't even know how many.
Yeah. So references you read. If you are writing a paper, you must have read a lot of references. If you are reading a lot of references from a particular journal or a few journals, that's a good indication. Another one, talk to your supervisor who do have more experience. So that is another resource, or even people you know. Okay. So I have people I met in meetings or just like this. If you think it's something close to physical chemistry, but if you're not sure if it's really appropriate for physical chemistry versus another ACS journal, Lamere, or analytical chemistry, sometimes I have a hard time. I choose JAX. For example, when do you choose JAX versus JPC? Well, normally, if you can publish in JPC, the content is okay for JAX. But JAX has a higher bar. Okay? They reject a larger percentage of it. So basically it has to be more significant, interesting to a broader audience for JAX. I only publish once in a while. And the JPC versus JCP is a more physics oriented. Physical chemistry is a more chemistry oriented, roughly speaking. And the chemical physics letters, which is a lower impact journal, faster communications. JPC later is a higher, better journal than JPC at this point in ranking for fast, timely publications. I would say those are the few, pointers. And then another thing, that's what I connect to that question. You submit to a journal, you may think it's appropriate. The editors give you feedback. If they reject it, normally the indication is not appropriate. They tell you, okay? They tell you it's bad science, poor writing, or just not appropriate. I do that. I try to give them a few lines when I reject. I said this is good work, but just not appropriate for JPC, or just this work occasionally is just so bad in English or the data. I said, this work needs a lot more work to improve. We try to be honest with the authors.
Okay, so thanks
Thank you so much.
for the interesting talk.
Thank you very much.
For tomorrow, Professor Zhang is going to deliver a talk for the